Welcome everyone. Here we are going to present a paper titled Effect of Trace Additions of Cadmium and Processing Conditions on Fracture Mechanisms of 2219 Aluminum Alloys, authored by myself, Dr. Sanjib Banerjee and Mr. Sanjib Gogoi from the Department of Mechanical Engineering, Tezpur University. "2219 aluminum alloys is one of the 2000 series aluminum alloys which have extensive applications in space, aircraft, automobile and marine. Here we can see the standard chemical composition of 2219 aluminum alloys. Regarding microalloying, recent trend in alloy development is microalloying, where contents would be less than 0.1 weight% with trace elements in order to achieve higher strength combined with reasonable toughness and maintaining lower density. The reason behind microalloying is that it permits addition of trace elements although of higher density but with lower content, and these trace elements even at lower concentrations may considerably influence the microstructural evolution and enhance the overall mechanical properties but without compromising the material weight. In the present work, 2219 aluminum copper alloys were processed by standard casting technique. The alloys were microalloyed with varying contents of cadmium, and the cadmium contents in the alloys varied from 0 to 0.1 weight% as shown in this table. After casting, the alloys were processed by standard thermomechanical treatment or TMT. Therefore, the alloys were first solutionized at 525 degrees centigrade. Then they were warm rolled at 200 degrees centigrade. And lastly, the alloys were age hardened at a precipitation temperature of 170 degrees centigrade for 40 hours because the peak aging time was evaluated to be 40 hours for the investigated solutionized alloys. After the thermomechanical treatments, uniaxial tensile tests were conducted. To evaluate the impact toughness, Charpy impact test was also performed following the ASTM standard technique. The fracture surfaces of both tensile and impact specimens were further observed under scanning electron microscope. Let us study about the salient features of the fracture surfaces. Here we can see the tensile fractographs of the cast homogenized alloys with cadmium contents of 0, 0.06 and 0.1 weight%. Here we can see the evidence of microporosities, then the dimples which are the evidence of plastic deformation, then the interface debonding, that is the debonding of the surface from another surface, particle debonding, we can see over here that debonding of the particles from the matrix region, then the crack or fracture of the particle itself, then we can see over here the evidence of micro crack and fracture. As it is evident over here, we can see a micro crack, then we can see the coalescence of microvoids we can see in many places. So these are the salient features which can be observed generally in the investigated alloys. Based on these observations of the present alloys, two possible sites of failure initiation during tensile loading was reported as, firstly, the pre-existing microporosities or shrinkage cavities which were formed during the solidification or casting itself, and secondly, the coarse, brittle second phases along grain boundary regions. Now, this theory was supported by the presence of coarse theta phase, chemically CuL2, and other intermetallic phases which have been detected at the grain boundary regions of the present alloys from SEM micrographs and further from the EDS analysis. Let us first study the influence of microalloying on the fracture surfaces of the investigated alloys. Here we can see the tensile fractographs of the cast homogenized alloys with 0, 0.06 and 0.1 weight% of cadmium. Now, the tensile ductility was observed to decrease due to trace contents of cadmium up to 0.06 weight percent. So such observation is correlated with the fracture surface of the base alloy, which is composed of entirely of dimples of cup and cone configurations, as we can see in this figure, and there was no evidence of brittle fracture. While for the alloys with trace contents of cadmium, as we can see in figure B and C, minor increase in features like crack, fracture, debonding of the brittle particles was however observed, which indicated at least a moderate level of ductility. To study the influence of peak aging, we can see in this figure the tensile fractographs of peak aged alloys with 0, 0.06 and 0.1 weight percent of cadmium. Now lower ductility with higher strength was recorded for the peak aged alloys compared to the homogenized alloys. Such lower ductility was correlated with the increased flat fracture surfaces, as we can see in these figures, evidence of wider brittle crack propagation and brittle interface rebonding, along with few dimple features representing an overall mixed mode of failure. However, the fractographs of the alloys with trace contents of cadmium, that is in figure B and C, it can be observed with larger flat fracture facets compared to this base alloy, which support the argument of still lower ductility associated with these peak aged alloys, especially after microalloying. While studying the influence of rolling, rolling results in optimum values of both strength and ductility. This is correlated with the presence of some flat fracture surfaces, as shown in these figures, along with abundant dimple features representing a mixed mode of failure. The fractographs support that rolled alloys had higher ductility compared to the peak aged alloys. To study the influence of strain rate, we investigated the impact fractographs over here, which exhibited fractured features predominantly of brittle or cleavage mode, because the fracture surfaces were majorly flat with the presence of cleavage facets and negligible regions exhibiting dimples. Here we can see a plot of impact toughness with cadmium weight percent, where we can see that compared to the homogenized alloys, the peak aged alloys had a lower impact toughness values, while the rolled and peak aged values have the highest impact toughness, and in all cases the impact toughness increased at 0.04 weight percent of cadmium. These are the few references regarding the present work. Thank you.